All right, so grade 8 guys and girls, we are into topic 4. I'm going to do 3 videos this week, plus some YouTube videos and some questions. So get ready for a big week. This topic is not overly hard. Lots of stuff that you're seeing here we talked about previously in the mix and flow of matter unit. So it shouldn't be all that crazy. And lots of the videos I'm going to put on are things that if I was teaching earlier, I kind of mentioned that I would put them on as things that you could watch and see. So we've already seen this formula here, pressure equals force divided by area. There's nothing too crazy about that. Oh, you can't see that. Only I can see that. Pressure equals force divided by area. So this is the amount of force that is like the push that we're putting. If you want to think about back when I was teaching this earlier, I know I took a textbook and I put it on someone's hand, and then I took that same textbook and I put a marker, and then I took a pen and I spread, and all the force, the weight of gravity acting on that book, being pulled down, is acting on it, and just putting it onto this pen, and it was putting pressure onto the person's hand. And then I replaced that pen with a pin which has a even smaller surface area. So that is kind of where I'm getting at. Force is, whatever the push or pull is. So whether it be gravity acting on that book, or whether it be me applying force this way, or, the force of gravity acting on a car when you want to use a jack to lift the car up. There's all sorts of things that are, can be force. And area is just that. It's the surface that the force is acting on, whether it be large or small. One of the videos I'm going to post for you guys is this one here, which is a world record for bed of nails, which this doesn't really explain how bed of nail works, but I'll talk about it briefly in a few seconds here. So when you look at this guy on the bed of nails actually laying there, those nails are absolutely sharp and they can do damage. But because there are many nails that are there supporting his weight, none of the nails actually are applying as much pressure to be able to puncture his skin. Rather, they are applying a small amount of pressure over a large area. Many, many nail heads taking up the pressure. So that kind of you'll watch the video, I hope, and it's actually quite amazing. I've already talked in my class about airbags. I'll post another video that I think I've shown once before. I don't know Mr. Dirkson's class if you guys watched the car accident video, but you guys can watch and see how much better your cars are today than old cars. But boxing, I watched a really interesting video. It was talking about one of the biggest cheats in boxing history, and the guy took all the stuffing out of his boxing gloves. And those boxing gloves, the reason why there is the stuffing in there is to take all of the force that comes from that punch and distribute it over a larger area so that the sport of boxing can last longer than, 1 or 2 punches, hopefully. Actually, I can't say hopefully. A good boxing match where it's a quick end is also quite entertaining. So that is kind of what we're talking about, though. The force is distributed over the entire area of that glove, and some of the glove takes some of the force of the hit instead of the jaw taking it. Same thing I talked about car accidents. This seat belt is there to take all the force of a car accident and distribute it across the entire length of your torso so that the car accident doesn't cause you to, die, for lack of a better word. Some car accidents, when they didn't have the restraint that went across your chest, it used to just be across your lap. People would hit their face on the steering wheel and it would break their bone across their nose or here, and that was always very bad. So all of these things are things that are distributing the force over a larger area. This is something I have done in the past. Of course, I can't really do it while we're away, but you can think about how an egg drop apparatus works. You can drop an egg from any height, not boiled, and it should, if the apparatus is built well, distribute the force over a larger area and keep the egg safe and sound. Excuse me. So this is demonstrating Pascal's law, which again we talked about earlier. But Pascal's law, there is equal amounts of pressure acting on each of these vessels, and that is the atmospheric pressure, the pressure of the atmosphere, everything, all the air from here to space, pushing down, being acted upon by gravity, and so it distributes the water out evenly. This is what I'm going to spend a bit of time with a video showing you guys. This is how hydraulics work. I know Mr. Dirkson's class, you guys did a thing where you had hydraulics and you had syringes and you did work by using the syringes to move stuff, which is super cool. I have a really good video that I'll show you on what's called a bottle jack. I'll put that on. And it shows you very clearly and concisely how it is that a bottle jack, which has just a teeny tiny piston moving up and down, does the work that it needs to do. Yeah, that's this right here. There is a multiplication of force. Like I worked in a car dealership for a little bit, and I didn't work in the repair department, the shop. I worked in sales, but I definitely went by the hydraulic lifts that they had and marveled at what they could do lifting wise. So if with those hydraulic lifts, there is a hydraulic ram or hydraulic pump that is pushing on in a small area that is distributing that force out over a larger area. Now, what has to happen with these is this small force either has to move farther to move this less distance. So if this moves far, like this is 9 squares if you count them. If this moves down 1 centimeter, it will only move this up 1/9 of a centimeter, but the force applied on this side will be 9 times as great on this side. It'll just move it less distance. So what typically happens is there's a hydraulic pump that pumps back and forth, and there's a valve typically somewhere in the system here. And so that hydraulic pump has a reservoir of fluid, and it'll push hydraulic fluid through past the valve and then lift back up. When it lifts back up, it'll suck hydraulic fluid back in, and it'll push the hydraulic fluid back through into the larger chamber. And again, every time it moves up and down, if it moves 9 centimeters, this moves up 1 centimeter, but at 9 times the force. So that is how these hydraulic systems work. And again, I have a really good video for you guys to be able to see that. And that gives us that mechanical advantage we talked about earlier, the multiplication of force, not necessarily the multiplication of speed. Although if you did push this down, it would force this to move very rapidly in a hydraulic setting. So hydraulics are used all over the place. All sorts of different industries use hydraulics. You guys should be able to do the math on this, I would think. This, one quick thing, this is cross multiplication. So if I take this times this divided by this, it'll give me the answer for this. So if I go, I'm terrible with math. So if I take 1200 and multiply it by 0.5, that gives me 600. 600 divided by 40 is, someone do some math and write me an answer here. And just put it into the notes on your classroom or on this assignment, and I'll be very happy with you. But cross multiplication is something that you will probably talk about sometime in the not too distant future in your math classes, and it's a very, very awesome principle that you can use. So with that, I'm going to call this video to a close, and I'm going to start recording the video for chapter number 5. See you guys in a little bit.